Alright, today we're going to be doing greatest common factor. So we're going to put these pages in our notebook. One of them will be turned to the side, and that's alright. And one of them will be upright. No big deal. And it is up to you and your preference on how you like to put that. The one that's going to be sideways. Remember, we're just using dots in the corners. It's plenty of glue. And we don't want to make it sticky so we can't write on it. Okay, this is greatest common factor. And greatest common factor are on pages 14 and 15. Okay. So there are several ways that we can find the greatest common factor. Something that we talked about yesterday with prime factorization is our factor trees. Those are very, very common in 5th grade and in elementary school. So, if we have our factor trees, we want to break it down to only prime numbers. So for 32, I can just think of 8 times 4. Neither of those are prime. So I'm going to break that down to 2 times 4 and 2 times 2. Well, 2 is a prime number, so I can go ahead and circle those. But 4 is not a prime number, so I'm going to continue to break that down to 2 times 2, which is prime. So for 32, we would write 2 times 2 times 2 times 2 times 2. Now, unlike yesterday, we are not going to put it with an exponent and put it in exponential form. Okay, we're going to leave it just like that. And we'll see why in just a minute. Okay, so for 40, we could break that down to 4 times 10. 4 and 10 are both composite. So break 4 down to 2 times 2 and 10 down to 2 times 5. And circle our 2's because we know those are prime. And 5 is also prime. So we're going to go ahead and circle that. So 40 would be 2 times 2.
I need all my North Nation dance team to make it to the media center in less than 2 minutes or you're running 2 laps. You have 2 minutes to get here. Sorry to teachers that are working, we did a little team bonding thing. All right, bye.
Okay, sorry about that interruption. So 2 times 2 times 2 times 5. So the reason we don't want to put it in exponential form is because I want to see how many pairs of the same thing do we have. So right here we have 2's, 2's again, 2's again, but nothing else in common. So we have 1, 2, 3 sets of 2's in common. So 2 times 2 times 2, which gives us 8. So 8 is our greatest common factor. Okay. Some of you may like that. It's an okay method for me. It's not my favorite, but if you get that, if you understand that one, then that's completely fine. You go ahead. Next is listing factors. I know that you guys are familiar with this. If we list our factors, I know that we have 1 and 32. 2 and 16, 4 and 8. Then for 40, we have 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So then what I like to do is go through and see which ones do they have in common. Well, they both have 1s, they both have 2s, they both have 4s, and they both have 8s. So since this is greatest common factor, which of these numbers that we underlined has the greatest value? Well, 8 does. So 8 is our greatest common factor. Now this way is okay, especially if you have numbers that don't have a lot of factors. That's okay. But when you have numbers that are really big, like especially when you get into algebra and factoring trinomials and things like that, you're going to need to be able to do that quicker than just listing the factors. So my favorite is the ladder method. With the ladder method, it's much like with the ladder method when we did prime factorization. You want to see which number can we take out of both numbers. Okay, well both of these are even, so let's take out a 2. 32 divided by 2 is 16. 40 divided by 2 is 20. Both of these again are even numbers. So we can take out a 2 again. 16 divided by 2 is 8. 20 divided by 2 is 10. Both of them again are are even, so we can take out a 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Okay. Now these are consecutive numbers. That just means they come right in a row. So they do not have anything in common. Numbers that are right next to each other on a number line do not have anything in common except for 1. So we're going to go ahead and make a big G for greatest around the side numbers. And we multiply everything that's inside of the G. So that would be 2 times 2, which is 4. 4 times 2, which is 8. So our greatest common factor is 8. Now it says check using the distributive property. The distributive property is one of the most important properties that we learn about in the 6th grade. So what that means is you're going to take the number on the outside, the number in the G, so for us that would be 8, and if I distributed that to what's on the inside, so we had 4 plus 5, okay, that was our leftovers. If I distribute 8 to 4, and distribute just means to multiply, 8 times 4 is 32. Bring down your plus sign. Then if I distribute my 8 to 5, 8 times 5 is 40. These numbers should be the numbers that you started out with. If they are, then that means that you have factored correctly. You have gotten out the greatest common factor. Okay, so a lot of we see this on homework, we will see this on calendar. So distributive property, take out the biggest number that you can And that gives us our greatest common factor. Then when you factor that back out, it gives you your original starting numbers. Okay, let's move on. It says to practice. We have 18 and 24, and check using the distributive property. Okay, so I'm going to put 18 and 24 in our ladder. (18) and 24 are both even, so I'm going to take out a 2. 18 divided by 2 is 9. 24 divided by 2 is 12. 9 and 12 are not both even, but I know that they're both divisible by 3. So I can take out a 3. 9 divided by 3 is 3. 12 divided by 3 is 4. We've got those consecutive numbers, so I know nothing else can be taken out. So put a G on the side. 2 times 3 gives us 6, so our greatest common factor is 6. I'm going to circle that. Then it says to check using the distributive property. So you're just going to put the greatest common factor on the outside of your parentheses, your leftover 3 and 4 on the inside, put a plus sign between them just so you can keep them separate. Then 6 times 3 gives you 18. Bring down your plus. And 6 times 4 gives you 24. Is this what you started out with? Yes, it is. So we know we have done this correctly. Our greatest common factor is 6. Let's do it again with 32 and 44. Okay, 32 and 44 are both even, so we know they're divisible by 2. 32 divided by 2 is 16. 44 divided by 2 is 22. Both again are even, so I know I can take out a 2. 16 divided by 2 is 8. 22 divided by 2 is 11. Both of these numbers are not even, so I can't take out a 2. They're not both divisible by 3. In fact, 11 is a prime number. So unless this was a multiple of 11, you really can't take out anything else. So we're going to put our G on the side. That means our greatest common factor is 2 times 2, which is 4. Check it with the distributive property. We've got 4 parenthesis 8 plus 11. Distribute your 4 to 8. 4 times 8 is 32. Bring down your plus sign. And 4 times 11 is 44. Is this what we started out with? It definitely is, so we know we have done it correctly. Okay. So the next thing we want to talk about is word problem clues. Sometimes it's a little bit confusing whenever you are thinking about greatest common factor and least common multiple, knowing which one to do. So here are some clues. If it asks for the most you can have of something, most is a synonym for greatest, so that's a way you can remember that. If it flat out asks you for the greatest amount, if it asks you for the largest amount. Largest and greatest, again, are synonyms. Or if you're looking for groupings of the most. Okay, so it says Miss Jones has 18 boys and 27 girls in choir. She wants them to stand in equal rows. Only boys or girls will be in each row. What is the greatest number of students that can stand in each row? So there's our clue, greatest. That tells me we're looking for our greatest common factor. So our numbers are 18 and 27. So we want to put those in the ladder. 18, 27. Draw your ladder. Both of these numbers are not even, so I can't take out a 2. But both of these numbers are divisible by 3, so I could take out a 3. 18 divided by 3 is 6. 27 divided by 3 is 9. Once again, they're both divisible by 3. So I know that 6 divided by 3 is 2, and 9 divided by 3 is 3. 2 and 3 are consecutive numbers. So we're going to put our G around our 3, or both of our 3's really. Multiply those together. And our greatest common factor is 9. And since this is a word problem, what are we talking about? The greatest number of students. So our answer is 9 students. Now, if I wanted to take this a step further, which I don't have to, but just in case we wanted to, I know that 18 represents boys, and 27 represents girls. So I know that there would be 9 students in each row. There would be 2 rows of boys and 3 rows of girls. Just something fun for you to know. Last one, Rosa is making a game board that is 16 inches by 24 inches. She wants to use square tiles. What is the largest tile she can use? Largest is a synonym for greatest, so that tells me we're looking for our greatest common factor. Our numbers are 16 and 24 inches. So we're going to put 16 and 24 into our ladder. Both of these are even, so I can take out a 2. 16 divided by 2 is 8. 24 divided by 2 is 12. Both of these are even. Take out a 2. 8 divided by 2 is 4. 12 divided by 2 is 6. Again, they're even, so let's take out another 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Consecutive numbers, so I'm going to make the G. And our greatest common factor would be 2 times 2, which is 4, times 2, which is 8. And what were we talking about? It would be 8 inches